Hello, welcome to the start of Chapter 2. This chapter is about lines and coordinate geometry. Now the first thing we have to do is see what we're going to learn today. 2.1, we're looking at slopes, parallel, perpendicular, and midpoints. So by the end of the day, you should be able to find the midpoints and slopes using their formulas and be able to recognize parallel and perpendicular lines based on their slopes. So first off, here are some formulas. This is the formula for slope, and often we use m as slope. So we'll say m equals y2 minus y1 over x2 minus x1. The midpoint is the point in the middle of 2 points. So if you have 2 points, you have to find the point right in the middle, and we add the x's, divide by 2, add the y's, and divide by 2. So if you need to pause the video and write these down. Now there's 3 forms of a line. There's standard form, ax plus by equals c. There's slope-intercept form, where y equals mx plus b, where m is the slope and b is the y-intercept. Now we have point-slope form, where m again is the slope, but we have a point, x1, y1, which we put into the equation there and there. We'll do much more work with this on the second day of this lesson, but today we're just showing you the equations, so make sure you have these written down, and if you need to pause the video, go right ahead. Now we want to talk about, we talked about this the first day when we were dealing with lines. How do we tell if lines are parallel? Well, 2 lines are parallel if they never touch, like this. What do we know about their slopes? Well, if you look, this goes up and over the same amount. So the slopes are equal. The slopes are equal in parallel lines. Now perpendicular means 2 lines cross at 90 degrees. So these are not equal slopes. This is a positive and this is a negative. And the slopes are also reciprocals of each other. So we can say slopes are opposite reciprocal. Now, what that means is, say if my slope number 1 is 2/3, my slope number 2 is going to be the reciprocal, which is 3/2, but the negative of that. And let's say I have another slope. Slope number 1, if it's 1/5, my slope number 2 would be -5/1, which is just -5. Or if my slope number 1 is -7, if negative of a negative is a positive, and since this is like 7/1, this should be positive 1/7. So that is the relationship between slopes if the lines are perpendicular or cross at 90 degrees. All right, now these are 4 points, and we want to first find the slope of AB. All right, now there's a few ways that we can find the slope of the points A, B. The first way is to put them in a table. These are your x coordinates, these are your y coordinates. So you go up here, x, y, x, y. So 1, -3, and 3, -6. Now, once I have them in a table, you see, how do I go from 3 to -6? I subtract 3. How do I go from 1 to 3? I go up 2. And slope is change in y over change in x. So slope is negative 3 over 2. Another thing you could do is do it on the graph. 1, negative 3 is this point here. I want 1 to the right and 3 down. 3, negative 6, 1, 2, 3, 4, 5, 6 is right here. So if I draw a straight line connecting them, I want to know that slope. So I have to figure out how far do I go over, which is 2, and how far do I go down, which is 3. Now we do rise over run, so this, again, would be negative 3 over how far we run, which is 2. So that's another way we can get it. Our third way of getting it is using the equation, y2 minus y1 over x2 minus x1. So now the y1, since we need numbers on this, those are the first ones and these are the second ones. So y2 is negative 6 minus a negative 3 all over x2, which is 3 minus 1. Now a minus a negative turns to a plus, and again that's going to be negative 3. 3 minus 1 is 2. So here are 3 methods: using the equation, using a graph, and using a table. Whatever works the best for you, go right ahead and use it. Now I want you to take a minute, pause the video, and see if you can find the slope of AC, CD, and BD all on your own. All right, hopefully you have paused the video, and if I did these with an equation, I'd do m equals y2 minus y1 all over x2 minus x1. So it'd be 1 plus 3, which is 2. 2 over 3 would be AC. To do CD, that is these two. Maybe I'll use a different color, blue. The slope would be 4 minus a negative 1 all over 6 minus 4. Minus a negative 1, that would be plus, so that's 5 over 2. So the slope of CD is 5 over 2. BD, I'll use green for. That's going to be slope is 4 minus negative 6 all over 6 minus 3. So this equals 4 minus negative 6 is like plus, so 10 over 3. So that slope will be 10 thirds. So those are our 3 slopes. So this first one was m equals negative 3 over 2. So which of the following segments are parallel and which are perpendicular? So if we look at these slopes, there are none of the slopes that are the same, so no parallel. However, these two are negative reciprocals. So AB and AC are perpendicular. AB and AC are perpendicular. Now in geometry, we have a really short way of writing this because a lot of things are going to be perpendicular. We just have 2 lines going up and down, then we do AC. So for right now, you can write either way. A, B, and AC are perpendicular, or if you remember the shortcut, that's acceptable also. All right, this next thing, we want to find the midpoint. Now I'm going to just throw this graph on here, make it small enough so we can actually use it. Wonderful. If I want to find the midpoints of AB, so I'm going to put A on them, 1, negative 3. Oh, that's down there. And now 3, negative 6. 1, 2, 3, 4, 5, 6. Oh, I missed that one too. Now the midpoint is going to be right in the middle, about there if I had to guess. Now where exactly that is, I'm not entirely sure. So what we use is a formula. You add the two x's together, 1 plus 3, and then you divide it by 2. And that's 4 over 2, which is 2. Now you add the y's together, negative 3 plus negative 6, and then divide that by 2. Negative 9 over 2 is negative 4.5. Now we have to think, does that look like about negative 2, negative 4.5? Well, we go 2 to the right, 1, 2, 3, 4.5 down. That's pretty reasonable. All right, now for AC, let's put those points on. We have A on there. Now we just have to put C on there. C is 4, negative 1. So if I drew this line, right in the middle looks like it's about there. So if I do the same method, 1 plus 4, maybe I'll erase this other stuff just so it doesn't get so confusing with too many lines. I add my x's, the 1 and 4, and then I divide by 2. I add my y's, negative 3 plus negative 1, and then I divide by 2. Well, this is going to be 5 over 2, which is 2.5. This is going to be negative 4 over 2, which is negative 2. Now, does that look like I go 2.5 to the right and 2 down? Yeah, that looks like the point in the middle. So that's pretty reasonable. So now let's try to identify slope and y-intercepts from the following equations. Now, if we're looking for slope and y-intercept, the best equation to deal with is the slope-intercept form. So we want to transform this to slope-intercept form. So the first thing I do is subtract 2x from both sides. So I have 3y equals 9 minus 2x. Now if I divide both sides by 3, I have y equals, now this 3 is divided by both of them. So 9 divided by 3 is 3. 2 divided by 3, we can just leave as 2/3. So the number in front of x is a slope. That's negative 2/3. The number over here is the y-intercept. Let's try another one. If you understood that, pause the video and try to do this one on your own. The first thing you do is subtract 4x on both sides. So we have negative 5y is equal to 20 minus 4x. Now I divide both sides by negative 5. So y is equal to negative 4. Negative over negative is going to be a positive 4/5 x. So 4/5 is going to be my slope. Y-intercept is negative 4. All right, slope and y-intercept. This one is like, it's like there's no slope on this one. It's like saying negative 3 plus 0x. So the slope is 0 and the y-intercept is negative 3. All right, we're getting near the end. Now if we want to find if an equation is linear or not, we have to first see if it goes up by the same amount each time. This one goes up by 3, up by 6, up by 12, and these go up by 1 each time. So the slope is different, 3 over 1, 6 over 1, 12 over 1. So this is not linear. Over here, this goes up by 3, this goes up by 3, and this goes up by 3. However, over here, this goes up by 6, by 4, and by 4. So this has a slope of 3 over 6, which is 1/2. This one has 3 over 4. So again, this is not linear. So let's try some more. This one's going up by 4, by 4, by 4, and over here is going up by 1. So since these all have the same slope, it is linear. So now we can write the equation. Well, we'd write y is equal to 4x, and if we can go back 1 from 12, that would be plus 8, because the y-intercept, if it's easy enough to do this, we can just go back and get it. So y equals 4x plus 8. Over here, we're going up by 1 and by 2. This goes up by 3, and this goes up by 6. This goes up by 2 and 4. Now this is 2/4, 3/6, and 1/2. And since all those are equivalent, it is linear, just like this one. Now the slope is 1/2, as reduced as I can. Now we have to find the y-intercept. So if I went back more, so if I went back down to 0, I'd go down 2, and so this would have to go down 1. So 0, 3 would be a point. So 1/2 x plus 3 is my equation. All right, now try to do the homework. Good luck.